Let's talk about surds in this video. Let's talk about surds, right? So a surd is the root of any number that would result in an irrational number. Okay. So if I say the square root of 2, right? So if you basically punched this number in your calculator and press that SD button, you'd actually get an irrational number. That's what we call a surd. On the other hand, if you have something like this, a 4, obviously if you would like punch this in a calculator, the answer would simply just be 2. So this is not a surd. This is not a surd. This is what we call a surd, a number that is under a root. I don't want to say square root because it could be any root, a cube root, square root, whatever. A number which is under a root, and as you would punch it in a calculator, it would result in an irrational number. That's what we call a surd, right? Okay, so let us just try and answer these few questions that you're seeing over here. Let's start with the first one. So for the first one, we have the root of 72. So let me just okay, the root of 72. So basically what you want to do at this point is that you want to break this 72 into a perfect square and another number. So this 72, you must break it up into a perfect square and another number. And you might be asking yourself, what is a perfect square? I mean, this is grade 7 work. A perfect square is a 4. What else? What else is there? 16, 25, 36, and all those numbers, you know, like as you keep all. I also forgot a 9, and but then yeah, all these numbers are what we call a perfect square, a number that you'd actually put underneath the square root, and then you'd get a perfect number, like a rational number. Like, that's what we call a perfect square. So this is what I'm going to do, and this is going to apply for all these examples that you're seeing over here. What I'm showing you now is going to apply for all these numbers that you're seeing over there. So the moment I have the square root of 72, you must break it up into a perfect square and another number. So obviously, the most quickest way is to just say 72 divided by 2. That will give us 36 times 2. As you can see, this 36 is a perfect square. So how you actually answer all these questions that I'm going to show you is that you must break it up into a perfect square and another number. A perfect square and another number, please. Okay. And then so let me just increase this a little. Okay. And then obviously we're going to apply the rules that are okay. In the first video that I actually did, right, there's this other first video that I did. In that first video, the first part of that video, I was actually explaining all the laws of exponents and surds and everything else. So what I'm going to do now is that I'm going to apply one of the laws that I've actually explained in the other video. So please just, make sure that you follow what I'm doing now. Okay. So now, basically what you're going to do in this step is that you're going to separate these two things, right? You're going to separate. How do you actually separate them from the laws? I've actually explained this in this video that I'm actually talking about, the first video that I made in the very beginning. So how you actually separate is that you're going to say square root of 36 times the square root of 2. And then now, since this is the 36 is a perfect square, obviously you can get an answer for that. It is 6, obviously, and then root 2. And then that should be your final answer. That is your final answer. It's as simple as that. Okay, let's try this one over here. Let's just write it down here. The square root of 98 minus the root of 32 minus the root of 18. So with all these three surds, right, I'm going to have to like separate these bases that you're seeing over there. But then as I'm separating these bases, I must make sure that in one of these two numbers, I have a perfect square and another number. A perfect square should be there, please. A perfect square should be there. So I'm also going to divide that by 2. 98 divided by 2 is 49 times 2. So I'll just say 49 times 2. Be careful, right? 49 is a perfect square. So that's why I'm allowed to do what I'm doing right now. 49 is a perfect square. If 49 wasn't like a perfect square, then I wouldn't have, like, what I'm actually doing now wouldn't have been allowed, if that makes sense. Okay, so I'm also going to do the same thing. I'm going to say 32. So it's 16 times 2. As you can see, 16 is also a perfect square. So I'm also going to do the same thing over there, right, with the 18. So what I'm going to do is that I'm going to say 18 divided by 2. I'm going to get 9 times 2. As you can see, 49 is a perfect square. 16 is also a perfect square. 9 is also a perfect square, right? Okay, so watch what I'm going to do now. I'm going to separate them, right? So I'm going to separate all these numbers. So as I'm separating them, this is what I'm going to have. The square root of 49 times the square root of 2 minus the square root of 16 times the square root of 2 minus the square root of 9 times the square root of 2. So basically at this step is that I just separated that, gave me this, separated that, gave me that, separated that, gave me that. And since 49 is also a perfect square, so that's just going to be 7 square root 2. And then that's also a perfect square, so I'm going to have minus 4 square root 2. That also I'm going to have minus 3 square root 2. As you can see, once you actually add this step, right, there are two ways of dealing with this. So let me just start the first way. With the first way, you can actually take this as an A or B or any other number. You can just substitute square root 2 with A. And then if you actually do that, look what are you going to have? 7A minus 4A minus 3A. As you can see, all these are like terms, right? All those are like terms. So you're going to say that 7 minus 4 minus 3, that is just 0, 0. A, the answer is 0. That is one way of dealing with this, right? Okay. One other way is that you can just factorize this. Factorize it and just take it out. Factor it out. Square root of 2. And then as you're factoring it out, what is left is 7 minus 4 and then minus 3. And then it's obviously answer is just square root 2, open bracket, and then you get 0 inside. That's why I'm putting in 0 there. That's why I'm putting in 0 there. And then the answer is just 0. Right? So let us go to C. But then just before we go to C, let me just erase this. If you don't understand, you can just rewind. You can just go back and then just, let us go to C right now. So with C, what we have is the square root of 12 plus the square root of 48 minus the root of 75. That is what I have. So I'm also going to do the same thing with this, right? I'm going to separate that, but then I must make sure that as I'm separating these individual bases, I must first have a perfect square and another number. That is important. So with this one, if you're going to say 12 divided by 2, obviously you're going to have 6 times 2, and then 6 is not a perfect square, so it's not going to work. So just make sure that with your two factors, one of the factors must be perfect square. So what I'm going to do there is that I'm going to say 4 times 3. Why am I choosing 4 times 3? 4 times 3, I know that is 12. But then I'm choosing 4 times 3 because I know that 4 is a perfect square. That is why I'm choosing 4 times 3. So I'm also going to do the same thing there. If I'm going to say 48 divided by 2, 48 divided by 2 won't give me those two factors that I'm going to have. One of those two factors won't be a perfect square, so I can't use that. So, but then one other thing that I can use is that I can say 16 times 3. Why am I using 16 times 3? Because I know that 16 is a perfect square. So I'm also going to do the same thing there. Obviously, if you say 75 divided by 2, you won't get any number. You get an irrational number, so you obviously can't use that. So 25 times 3, right? Once you're at this point, you're going to say that you're going to separate them now. So it's square root of 4 times the square root of 3 plus the square root of 16 times the square root of 3 minus the square root of 25 times the square root of 3, right? So you're also going to do the same thing here. So obviously that is 2 root 3, and then that is 4 plus 4 root 3 minus the square root of 25 will give us 5 root 3. So you're also going to do the same thing. You can just say let is equal to root 3. So you can just say 2a plus 4a minus 5a. It's the same thing that we did the other time. The reason why I'm actually doing what I'm doing now is to show you that I can actually take these this whole expression that I have here as like terms, because they're basically like terms. So now, as you can see, when this expression is in this form, you can exactly see that what we have here is like terms. So just go ahead and add them. So you're gonna have 2 plus 4, which is 6a. 6a minus 5a, it's 1a. And then don't forget to put that a back into the square root of 3. So the answer is just root 3, right? It's as simple as that. Okay, so let's go to D, and then right before you go to D, let me just cancel. Oh, okay, I don't know what happened there. Delete. Okay, let us go to D. So with D, I have 6 plus root of 18 over 3. So obviously I have an 18 where 18 is a surd. Why is a surd? I've explained what a surd is. A surd is any number that is under a root that if you punch that number in a calculator, you'll get an irrational number. So we have a surd there, as you can see. So what I'm going to do with that surd is that I'm going to have to separate that base into two factors, and one of the factors must be a perfect square. One of the factors must be a perfect square. So watch what I'm going to do now. I'm going to say 6 plus the root of, with this one I can just say 9 times 2. Why am I choosing 9 times 2? Because 9 is a perfect square, right? And then I'm going to say over 3. So I'm going to separate that as I was always doing. I'm going to separate that. I'm going to say 6 plus that is going to give me the root of 9 times the root of 2 over 3. That's what I'm going to have, right? But then obviously the root of 9 is just 3. So the answer that I'm going to have is 6 plus 3 root 2 over 3, right? But then I know that as a learner, you're just gonna rush and be like, oh yeah, I'm done now. What? No, you're not exactly done. Well, it is simplified, but then not fully simplified. Not fully simplified. Why am I saying this? Because there's 3, there's 6. So you can clearly take out 3 as a common factor. So obviously, if you have a 6 and then you're trying to take out 3 from a 6, what is going to be left? It's 2. So it's 3, open bracket, there's a 6 there. If you're taking out a 3 from a 6, don't take it as a minus, no, take it as a division. 6 divided by 3 is going to give you 2. The reason why I'm saying this is because when you're trying to go back, you're going to have to say 3 times 2 to give you 6. Don't say 6 minus 3. No. That's not how factorization actually works. So here, if I have a 3 and then you're taking out a 3, what's left is 1. So I'll just say the root of 2. And then I'll just still have a 3 underneath it. So that's what I'm going to have. So obviously that will just cancel that. Now, this is what I have left. 2 plus the root of 2. Now this is simplified. There's nothing else you can do at this point. Okay. So now let us just go ahead. But then these ones are plain easy. But then I'll just try and explain them to you, right? There's another thing that you must actually know before I can actually start with these examples that I'm going to start with, is that if I have a root of x and then I'm going to multiply it with another root of x, just know that the answer is x. The answer is x. Why am I actually saying this? Because the root of x is just x to the power of a half times x to the power of a half. And then since I'm multiplying two bases which are the same, I'm going to have x to the power of half plus a half. When you multiply bases which are the same, you're going to have to make sure that you add the exponents. This is just how everything works. So it's x to the power of a half plus a half is a 1. Come on now. It's a 1. So anything to the power of 1 is just that. So it's x. So please bear in mind. So, okay. So with this one that we're going to touch right now, there are basically two ways that you can actually do these sums that you're going to see. But then let's just go with the most safest way. Let's go with the most safest way. And then once you actually get comfortable with these sums that we've been doing, then you can, branch out and then just try and look for other ways or other simpler ways that you can use, but then before that, let's just go with the most simplest and safest way. Right. So with this one, as you can see, I'm multiplying two terms together. Right. In this bracket that I have here, I'm just take this as A plus B, and then the other one is just A minus B. So obviously, if you have something like this, A plus B, A minus B, this is from grade 8 or grade 9. This is, you use FOIL. It's the FOIL method. Yeah, this is grade 9. You use FOIL. So you're also going to do the same thing. Yeah, FOIL. I just hope you still remember how FOIL actually works. FOIL is first. First is the first term multiplied by the first term. So I just said now that the root of 7 times the root of 7, the answer is just 7. Right? Okay, I like that. And then O is for the outer. Outer is root of 7 times negative 2. Please do not forget the sign. So the answer is going to be the root of 7 times negative 2. Let me just put my brackets there. So the answer is just negative 2 root 7. Right? Okay. And then I is for inner. I'm going to multiply that. So it is just 2 times the root of 7. The answer that I'm going to get is 2 root 7. And then L is for last. So that means 2 times negative 2, please. 2 times negative 2. So the answer is negative 4. And then you just, mix all these things. So it's 7 minus 2 root 7 plus 2 root 7 minus 4. And then you need to deal with always you deal with the inner terms. So as you can see, all these are like terms, right? They are like terms. So it's just, you can just say let 7, the root of 7 is equal to A. So that means you're going to have negative 2A plus 2A. So as you can see, all those the thing is, those two middle terms will just cancel out each other. So as they canceling out each other, so we're going to have 7 minus 4, which is 3. Or another way that you could have also seen this sum was, this is actually a difference of two squares. A plus B, A minus B. We call this a difference of two squares. So obviously the answer should always give you A squared minus B squared. So you could have just said the root of 7. The root of 7 squared minus the root of 2. So the answer would have gave you negative, not negative, sorry, 7 minus 4, which is 3. But then I'm not really comfortable with this one. I would actually feel comfortable with you using this one as like maybe after doing so many questions, when you're actually comfortable, not now. When you're starting out, just use this plain old simple method called the FOIL method. This is the one that I'm actually comfortable with. So we're also going to do the same thing here, right? So FOIL. We're also going to do the same thing. So first is this times that. So you're going to have 2 root 2 multiplied by 2 root 2. So please do not use your calculator. Like, you must actually get used to what we're doing now. If you don't get used to what we're doing now, then when you get to grade 12 or when you like doing very complex sums, you won't know what to do. That's good. It's literally going to get confusing for you. So just let's do it the long way around. Please don't use a calculator. So how you actually solve this, you start with the numbers first. 2 times 2. 2 times 2 is basically 4. And then after that, you can just multiply the surds together. So the root of 2, we just did it now. The root of 2 multiplied by the root of 2 is just 2. So you just put a little dot with a 2. So 4 times 2 is 8. It's simple. So let's just go over it again. So it's 2 times 2, which is 4. The root of 2 multiplied by the root of 2, which is 2. And then 4 times 2 is 8. Simple as that. And then we go to the O, which is outer. We go to the O, which is outer. Right? So now with the outer, what we're going to have is 2 root 2 multiplied by negative root 3. Okay. So now, obviously, the numbers that are outside the root is only 1. We have 2 here, but then we don't have another number there, so it's just going to be 2. With this one, with the numbers that were outside the root, we had 2 on this side and we also had 2 on the other side. So we just multiplied those two numbers. But this one, there's no number outside of the root, so there's nothing else. You can just put a 1 there. Just say 2 times 1, which should give you 2. And then now, since you've done multiplying the numbers, so you're just going to go to root 2 times root 3. So this is what you're going to do then. You're going to say 2 times 3. That 2 is this one. That 3 is that. So, but then we all know that 2 times 3 is just 6. So you can just put a 6 there. I don't know if that makes sense. You just put a 6 there. And then positive times negative will always give us a negative. Positive times a negative will always give us a negative. So you also do the same thing with I, which is the inner. I is the inner. So you're going to say the root of 3 multiplied by 2 root 2, right? So there's no number. So we do it again. There's no number outside of the root then. So if there's no number, you just put 1 there. There's no just put a 1. So it's 2 times it's 1 times 2. So you're gonna put excuse me, just gonna put a 2 there. And then the root of 3 times the root of 2, it's just the root of 3 times 2. 3 times 2 is just 6. That's what we have over there. And then for the L, what we're going to do then is just the last. That's what we do last. So you're going to say the root of 3 times the root of negative root 3. So let's start with the sign first, because that also can be confusing. Positive times negative will give us negative. Positive times negative will give us negative. And then the root of 3 times the root of 3 will always give us 9. Right? And then just 8 minus 2 root 6 plus 2 root 6 minus 9. And then these are the middle terms. And then as you can see, in this instance, they also cancel. I hope you see that. They also cancel. So they cancel. And then what you have left is 8 minus 9. The answer is just negative 1. Right? Here is another one. So the moment, okay, with the moment you see something like this, just think of what I'm going to show you now. It's the same as a minus b squared. So obviously how you get rid of the squares, you can just say a minus b. So it just means that 2, that little 2 that you're seeing there as an exponent is just telling you that there are 2 of these things that you're seeing there. There are 2 of the a minus b. So this is what you're going to do there. I hope you understand. So similarly, that is what we're going to do there. So I'm going to say 3 root 3 minus the square root of 8. And then I'm going to open another bracket as well. 3 root 3 minus root of 8. I close my bracket, and then I can use the FOIL now. So F is for the first, so you're gonna say this times by that. So it's 3 root 3 times 3 root 3. So the answer is 3 times 3. You start with the numbers which are actually outside the root first. So which is 9. And then after that, we're going to say root 3 times root 3. Root 3 times root 3 should give us 3. So 9 times 3 is 9, 18, 27. So that is 27. And then we go to the outer. So for the outer one is this times by that. So first of all, it is root 3, 3 root 3 times by negative root 8. Right? So positive times negative, we first start with a negative, obviously. Right? And then 3 times 1, because with this one, there's no number that is outside the root. So it's going to be 3 times 1. 3 times 1 is just going to be 3. And then 3 times 8. 3 times 8, you're going to open the root like that, and then you're going to say 3 times 8. And then now what you actually do at this point, just as I've shown you in the other not the other video just now, I'm going to say 3 times 8, which will give you 24. Sorry for that. 24. Right? Okay. And then we go to the inner. Inner is this one multiplied by this one. So it is negative 8 times by 3 root 3. So it's literally the same. Positive times negative will give us a negative. 3 times 1 is 3. And 8 times 3. 8 times 3. It's just 24. 24, right? And then lastly, it is that times that. So it's negative square root of 8 times negative square root of 8. So negative times negative is positive. Root of 8 times root of 8 is just 8. So obviously what you then do is you say 27 minus 3, 24 minus 3, 24, right? And then plus 8. These are like terms, just as I've been showing you in the other example. Those are like terms. So you need to know what to do with those like terms, right? So negative 3 minus negative 3 is negative 6. So, but then let me first add these ones here. 27 plus 8 should give me 35. So it's 35, and then this one is just negative 6 root of 24, and then do you do the same thing? That is a surd, right? Because this is not fully simplified. We're trying to fully simplify what we have now, right? So as you simplify, and please make sure that this 24, you're going to have to like divide it into 2 factors, and one of the factors must be a perfect square. Don't forget that. So it's going to be 35 minus 6, the root of, obviously it's going to have to 4 times 6, because 4 is a perfect square. Yes, I like that, I like that, I like that. So it is 35 minus 6 times the root of 4 times the root of 6. And now the root of 4 is just 2, so let me just say 2. Right? And then 6 times 2 is just 12. So you can just say root of 6. That is the final answer. That is most certainly the final answer. Okay, here's another one. So you still use the same method, right? You still use the same method, the FOIL. Still use the FOIL. So F is for first, that times that. So obviously it is going to be 2 root of 16, right? I just hope you understand what I'm doing, because I've been explaining, I've been going step by step. So I just, I don't know what's the same, but then it's fine. You do understand what I'm trying to say. So our term is this times that. So it's going to be 6, it's 12 root 2, right? Please don't use a calculator. I beg. I beg, please don't use the calculator. Inner is this times that, so it's negative 6 square root of 8, right? And then L is for this times that, so it's 6 times negative 36. So the answer should give us 2 root 16 plus 12 root 2 minus 6 root 8 minus 36, right? Okay, let's carry on. So square root of 16 is obviously 4, so it's 2 times 4. 2 times 4 is obviously 8, so let me just put my 8 there, right? So what I actually did was, the square root of 16 is 4. 2 times 4. I just hope you understand what I did. 2 times 4, which is 8. So I'll just put my 8 there, and then I'll just say plus 12 root 2. And then with this one, I'll just say 6 square root of 4 times 2 minus 36. I just I dealt with that surd that I'm seeing over there. So obviously 8 is 4 times 2, and then 4 is perfect square. Please don't forget that perfect square. So before I go any further, I can just say 8 minus 3. 8 minus 3 must give me 5. No, 36. Why am I saying 3? It's 36. Sorry for that. So it's 8 minus 36. So that should give us negative 28. Negative 28, and then plus 12 root 2 minus 6 times root 4 times, okay, let me just, for consistency, root 2, right? And then obviously that is also 2. The square root of 4 is 2. So it's negative 28 plus 12 root 2 minus 6 times 2, right? Because the root of 4 is 2, and then square root of 2. So 6 times 2 is 12. So this is negative 12 here. So it's going to be negative 12 root 2. Negative 12 root 2. And then obviously, these are like terms. So it's the same thing as 12a minus 12a. So they'll give us 0. So the final answer is just negative 28. Simple, right? All these things are basically simple. I'm telling you, all these things are so simple. Very, 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 very simple. Right. Okay, here's another example, right? So with this example, first of all, I see a number there and I see the number there. So I need to like split those numbers into a perfect square and another number. That one thing that I've always been saying, when you split it apart, make sure that the factors that you choose, one number should be a perfect square, the other number should just be any number, any other number, it's okay. So what I'm going to have here, 6 times the root of 2x to the power of 8 minus 2 to the power of 8. I'm just going to say 4 times 2 at times x to the power of 8. That's what I'm going to do. Right? And then I'm going to say over 4 times 2 times x to the power of 8. That's what I'm going to do at this point. So obviously I'm going to do the same thing there. So I'm going to say 6 times 2x to the power of 8 minus 2 times the root of 4, right? And then times the, so now what I'm actually going to do is that I'm going to try and keep the 2 and the x to the power of 8 together. Because why am I actually doing that? Because I actually see a 2 and x to the power of 8 together. I don't know if like you understand where I'm going with this. Because now I should actually put the 2 in the root alone, and I must also put the x to the power of 8 alone. But then that is not the root that I'm going to go with, because now since here the 2 and the x to the power of 8 are together, are bonded in a way. So I'm also going to try and mimic the same thing, because I know that eventually I'm going to have to factorize something which is common. So like I'm actually thinking ahead. So I'm going to just say 2 to the power of x, 2 times x to the power of 8. That's what I'm doing here. So I'm going to say over. So I'm also going to do the same thing here. So I'm going to say 4, and then I'm going to say times open bracket 2x to the power of 8. So it's the same thing. But then I know that the square root of 4 is just 2, so I'll just put a 2 there. The square root of 4 is 2. But 2 times 2 is 4, so I can just put a 4 there. So I can just put a 4 there. 2x to the power of 8. So I'm okay here. There's nothing else that I can really do. As you can see, this is what I was actually trying to factor out. This, you see, common factor. That is what I was trying to factor out. Right, that is what I was trying to factor out. So as I'm taking it out, I'm going to say 2x to the power of 8 with its root. Then I open the bracket. What's left is 6. So here, I'm also going to take that whole thing out. So I'm going to say 6 minus 4. Because as I'm taking this whole thing out, the only thing that is left is 4. So that is the 4. So I'm going to say over here I'll just say 2 to the power of x to the power of 8. Since, as you can see, these two are the same, I can just cancel them. So, oh, there was a 2. I keep forgetting this, man. There was a 2 there, right? So 6 minus 4 is 2 over 2. So the answer should just be 1. Okay, so with this one, I'm going to teach something new called rationalizing the denominator. So this is also just as important. We call it rationalizing. I need you to so let me just write it down here. Rationalizing the denominator. Rationalizing the denominator. So what the question is asking of us is that we must prove that the left hand side is actually equal to the right hand side. So the left hand side actually goes like this. It's 2 the root of a over a plus 2b over the root of a. Right. So obviously the most common or the most natural thing to do at this point is just to get the LCD. Right. So obviously the LCD, just multiply these two things. It's just a root a. That's the LCD. I just hope, okay, that's fine. Let's just do it the long way around, because right now what I'm actually doing is that I don't know if you still remember the basics of grade 10 or what. Then it's fine. Let's just go. Let me just assume that you forgot everything. It's fine. So if this is the LCD, so that means that with this one, this whole thing, I need to multiply with the root of a. So it's 2 root a times root a over a root a. So times the top with root a, the bottom with also root a, plus, and then I have 2b. But then with this one, I just multiplied with the a, right? Because of the LCD. So it's going to be a over the square root of a. Then I also just multiplied with a. So that's what I have at this point. So obviously, root a times root a is just 2a. So the answer is 2a over a root a, like that. And then this one is just plus 2ba over a root a. So the answer is 2a plus 2ba over a root a. Okay, this is what we have at this point. Okay, we can actually carry this further. I have a there, so that means I can factor out the a as a common factor. So I'll say a open bracket 2 plus 2b. What I'm actually doing is that I took out the a there, also took out the a there as a common factor, and then I also have an a which was underneath. So what I'm left with is this. So now what I want to do at this point is that I want to cancel that a with that a. I cancel those two a's, so equal to 2 plus 2b over the root of a. So back to what I actually introduced 2 minutes ago, 3 minutes ago. We rationalize the denominator. So basically what that means, rationalizing the denominator, is that your final answer should not have a surd as a denominator. Yeah, that's what we call rationalizing the denominator. So I'll say it again. The final answer should not have a surd as a denominator. The final answer, this final answer, should not have a surd as a denominator. So that means that I need to get rid of that surd. So obviously, for me to be able to get rid of that surd, I need to multiply it by itself at the top and at the bottom. Okay, let me just explain that whole thing. So obviously, root of a over root of a, this is just 1 because that divided by that is 1. So that's what I'm actually going to do there. So me multiplying this with a 1, I'm not really changing anything, because 2 times 1 is just 2. You're not changing anything. So if I multiply this whole thing by 1, I'm not changing anything. So that means that I'm going to say root of a at the top times root of a at the bottom. So again, I'm not really changing anything because this is actually 1. Right? This is 1. So multiply anything with 1, nothing changes. But then watch what I'm going to do at this point. I'm going to say root of a times root of a. Root of a times root of a is just a. So it's 2 plus 2b, and then multiply by that a. So it's root of a over, right? Watch what I'm going to do. Over root of a times root of a, that is just a. And then there, that is it. You can just leave it like this if you want. Or you can just factor out the 2 if you want here. You can also factor out the 2, like 2 root a, open bracket, 1 plus b over a. It doesn't really matter. As long as your final answer does not have a surd as your denominator.